Hello and welcome to the webinar, Mastering 3D Modeling. My name is Neil Cook and this webinar is relating to a brand new ebook that we just downloaded that we just uploaded to our website this week. This new ebook has a lot of tips and tricks with regards to creating robust 3D models, a lot of do's and don'ts as well, and plus everything that we're going to discuss in this webinar plus more. The URL there is at the bottom of the screen, and I will remind you of that at the end. It's worthwhile downloading as a reference, but we will be covering most of the topics in the webinar today. And if you've got any questions regarding anything, you can use the question panel in the GoToWebinar to ask the questions, and I will stop periodically and hopefully answer those questions for you. Okay, let's get started. So today's goals, we're going to be looking at different ways you can learn 3D CAD. A lot of the topics and techniques that we'll discuss today will apply to any 3D CAD program, but clearly we're going to focus on Onshape because, of course, you're signed up for an Onshape webinar. So we're going to look at different ways you can learn Onshape. Then we'll take a look at some techniques for creating good, robust, and easy to predict sketches, how to build a robust 3D model, and an topic called behind the scenes. And what this really is talking about how the parametric modeler works. So when you keep these things in mind, it'll help you to build better models. Then we'll take a look at some techniques of how you can plan ahead when you're creating models, and also what you should do when you finish. And at the end, we'll have some Q&A. We might not take the full hour here, so please feel free to stop and ask questions as we go along. Okay, to learn Onshape, there is a number of options. We released a new learning center 2 or 3 months back, and you can find that at learn.onshape.com. Now, on there are a number of options. If you are a free user or a public plan user, there is this QuickStart guide, which you can see here. This is free for everybody, and this will give you an overview of what Onshape is, how you use it, what Part Studios and Mates and all these kind of things is to get you going within Onshape. If you are a professional plan subscriber, there are 2 learning pathways available. One is the fundamentals of CAD, and what that will do will go into essentially every feature within Onshape and go in there in detail and show you how you would apply those to your design. Next one is talking about data management, so that's going to talk about versioning and branching and merging and all those other topics that relate to managing your data within Onshape. Other options here are virtual instructor-led training. Now, these are paid-for training style. They're instructor-led training, and it's virtual in that you'll do it over the web. So there is an Onshape bootcamp, which is, I think it's 8 hours spread over 3 or 4 sessions within a week, which will instructor-led, goes through all the basics of bootcamp of Onshape and gives you all the information you need. Then we just released a new one for sheet metal, and there's also one there for top-down design. I say if you're interested in those are paid for. You should speak to your account representative if you are interested in attending those. What's also good with the learning pathways for the web, though, is there are also some exercises in there, so you can apply your techniques that you've learned to see how well you've learned them, and then there's certificates available at the end as well if you want to become certified in using Onshape. There's a question there saying, can I access the learning pathway with a student account? That is a good question, and actually I don't know the answer to that, but I can certainly find out. Again, you could speak to perhaps the account representative or post on the forum or something like that, and we'll find the answer to that for you. Okay, and finally, on the actual Onshape website itself, there is a menu called Learn, and if you click on that, you'll find, first of all, a link straight to the new Learning Center, but also there is the video library, which has got all the well, it's got hundreds of videos covering every topic within Onshape, from design through to creating custom features with feature scripts and assemblies and everything in there. Plus, every webinar we do is also recorded and available there as well. So chances are, if there is a particular topic you want to learn about, you will be able to find it here, either in the video library or in the recorded webinars. Okay, so it's important that you do training. If you're like me and just like to jump straight in, then this will help you. But the difference is what we're going to talk about today and learning a CAD system is that typically learning a CAD system is about how you press the buttons, what the buttons do, in which order you should do it. The topics we're going to look at today is how you can build a robust 3D model so it becomes easy to modify. Okay, so let's jump right in and talk about sketching. Okay, so the first thing we're going to talk about is dimensions and constraints within a sketch. Now, if you've done any of the training at all of you, or you've played around with sketching, you realize there are two types of ways you can specify how something behaves in a sketch. There are the constraints, things like concentric, equal, symmetry, those kinds of things. And there are dimensions, which will give you the physical sizes. Now, what I'm recommending here is that you always prioritize constraints over dimensions, and I'll show you a good reason why. Plus, when you're doing this, is that you want to capture design intent, not manufacturing intent. When you get to your creating your drawing at the end, then you should apply your manufacturing intent based off one or two datums. But from a design intent, it's very important to capture the information that describes how the part should behave within its intended use. And if you do this, it makes things easy to understand, easy to edit, and most of all, predictable. I'm going to keep coming back to this word predictable because when we're talking about building robust 3D models, we want to make sure that when we make a change, your part's going to update as you would expect it to. Okay, so I'm going to go back to my, let's go to Onshape and let's take a look at this as an example. So when we actually create a sketch, there are a number of things we can do. So for example, if I'm going to do a very simple sketch, and we'll just do something like this with some steps. Okay, now it may be tempting from a manufacturing standpoint to dimension from a datum. In this case, is this point here. So we might have a dimension there, a dimension here, and then as we add these dimensions, okay, and one, and then dimensions for these heights, and then once all the items are blue, it's fully constrained. Okay, now there's nothing wrong with that, but it all depends on what your design intent is. If it's supposed to be an equally stepped kind of block step thing, whatever it is, then it will be easier to use constraints than it would be for dimensions. So if we take the same thing and build it with constraints, and again, it all depends obviously what the thing is that you're actually building, but if you're to build it with let me just undo those rather than, if you're going to do with constraints, then you might want to say that these two things here are equal, and then these three lines and these three lines are all equal as well. Then it just means that whenever you do this, you know this thing is going to scale. So just by using constraints and just having one dimension in there, it makes it not only easy to understand what's going to happen when you make the design changes, but it helps you to capture that design intent. And it also means that the actual sketch solver has a lot less work to do. And also you have a lot less work to do when you come to make design changes. Let's take a look at another example here, probably a little bit more relevant. If I put in a center rectangle in here, and if I hold down the Alt key, it will make it square. So let's make that 100. Okay, and then and let's do it again. And this time we'll have a constraint. Let's make this say 70, and then we'll put a a circle in the middle, which is 25, and then perhaps some circles around the outside. It's 15. Just make all these the same. So we'll just sketch these in. So in this example, rather than actually doing it all in with dimensions, with very little information, we've managed to capture a lot of the design intent in here. So it's essentially it's a 100mm square plate with a 25mm hole at the middle, and then four 15mm holes at a 70mm spacing apart. So you could actually, it's probably a good exercise if you're trying to make your sketches simple and reliable and repeatable, is if you can physically describe it in words what the part should do. You know, the other alternative for all these, of course, is to, you know, again, dimension from a datum. So if you're doing it from, you know, from a datum, you've essentially got to do every single dimension. Okay, there are still some constraints on here, which is why that's gone grey on there. But you can see you'd have to put in a lot more information to actually define that if there's none of these constraints on here. So otherwise, you'd have to go around and add dimensions on every single piece of geometry, and also, and then it makes it harder to see what's going on and make changes to the part once you start in adding too many dimensions on there. Okay, so we recommend keeping prioritizing those constraints over those dimensions, just to make it more obvious what the dimensions are doing. Oh, sorry, what your part is doing even. Okay, so dimensions over constraints. The next thing we'll take a look at is sketches versus feature fillets. Now, when you actually create a sketch, there is an option in there that you can create fillets on the edges. Now, this is fine if it's a simple plate that you're creating, but if you're doing something a little bit more complicated, then it's really not a good idea to add those fillets in there unless they are absolutely necessary. Now, one way I like to look at it is if the feature is or the fillet I should say, is a functional feature, like the round on the top of here because it's concentric to this hole, then you should add it in the sketch. However, if it is just a cosmetic fillet, like breaking a sharp edge, you should do that in the model itself. Okay, but the idea was, or the one I'm going to keep coming back to, is trying to keep your sketches as simple as possible. If you overcomplicate things, it's going to make things a lot difficult for you. Okay, so again, if you go back to here, and we'll go to this same example. Now I'll just sketch that shape again. Now, what we're going to do is to make use of things like symmetry. And again, we'll come back to this later, but symmetry is very important, again, for capturing your design intent. Now, you might want to do things like, in that particular design, clearly the big hole is the important diamond, is the important feature, I should say. So we should always start with that. Next, you might say, okay, well, the other holes are the next most important because they're going to define the position of the part, or how it functions within the assembly. Now, there's a number of ways we can build this. Really, from for speed purposes, what I might want to do is to draw in, say, perhaps half of it, and use the mirror command. Now, a nice use of symmetry for planes, which you might not realize, is that when you use the mirror command in Sketch, it always asks for a mirror line. Now, you don't actually have to have a center line, or you don't have to have a solid line. You can actually use the planes. So if that's a mirror line, then you can quite happily go ahead and mirror those around there. So that's just a nice quick way to make symmetry around your model. And again, all you need to do then is just finish this up. Now, when you position that, you can see it's going tangent to one arc there. And because we've got symmetry in there, we know that this is going to be perfectly tangent on both sides. Okay, so it's a nice quick way to dimension that. Likewise, my design intent that these things need to be 80mm apart. And then, the distance here is going to be, say, 25, and the distance here is going to be 25. Now you can see we're starting to get the sketch completely black, and the only bits of information we need to add now is to make this thing finish. Okay, sorry, I'm missing the dimension is the height, the position of those two. Let's make that, say, 45. So there's my finished sketch. Now what you'll see here is that this arc here is absolutely crucial, because if you wanted to do that as a sharp point, it just really wouldn't make any sense, because it's concentric to this hole. Now, the other option is to is then when we extrude this part, is then to make sure you use feature fillets rather than sketch fillets on any edges which are only break edges. So if there's nothing, if they're just cosmetic, then please use the feature fillet rather than a sketch fillet. Now, if you did want to make some changes to this and perhaps make these fillets at the bottom concentric to here, it's a little bit more tricky, because you could use variables to link them together, but there's no way to actually say that this fillet at the bottom here should be concentric to this hole. So again, this is a good reason why you would do it, those particular ones, in a sketch fillet. In fact, let me just cancel that. Let's go back to that original sketch and just add those sketch fillets in. Now, what I'm going to do here is, well, two things. First of all is add these fillets in, but also do some troubleshooting on a sketch and look at what happens when things go wrong. So, for example, if you've got this here where we've got measured 25 in each direction, we've got a radius 25, we've got this 80, we've actually over-dimensioned this sketch. And the reason it's allowed me to do that is because there is no relationship between this arc and this circle. So what we could do is, let me just select that vertex and that vertex, the one that lie on top of each other, and use concentric. And what you'll see is that once I've done that, is that everything now goes red. So it's basically, Onshape is telling me that there's a problem here because I have got conflicting constraints within this sketch. Now, what to do to fix this? Now, there's a number of things we can do. First of all, you can say, well, actually, that probably, we could get rid of this dimension when it's still not fixed, and get rid of this dimension, okay, and now it's fixed. So that kind of makes perfect sense on how you would want to dimension this. So, we make the assumption that these centers are coincident, and then we've had that radius dimension on the edges there. Okay, and then if you really want to make that a full round, okay, then you might want to do a little bit more work here. So for example, let's just get rid of these points here. Now when we move these things around and make that coincident with that, okay, we can now sort of make these two coincident and these two coincident, and select these two and make them tangent. Okay, so again, that's the different types of styles for a bracket like this, whether they are square, whether they are rounded off, is how you would decide whether you put the sketch fillets in the sketch itself. In general, leave them out, but in instances like this where it's critical to a coincident position on a hole, for example, then always put those in the sketch itself. Okay, the more things you put in a sketch, the more difficult it is to be able to troubleshoot it, add constraints, understand what's going on. Which brings me on to the next topic. which is talking about sketch overload. Now, this is a real sketch that I got from the public library. And if you take a look at a sketch like this, if you look at the number of dimensions and constraints on there, you have to ask yourself, what could possibly go wrong? First of all, there are too many dimensions and constraints. But what you need to understand is it's taking a long time to actually build that sketch, but it's also doing other things as well. For example, you will get a performance hit because if you think about, the sketch solver has to solve like hundreds of simultaneous equations, and the more information you put in one single sketch, the more equations it has to solve. So things will start to slow down as you're adding dimensions and constraints on something so busy. So it's a good idea to actually break sketches down into more manageable pieces. And really as well, from a usability standpoint, if you've got that much information in one sketch, then trying to troubleshoot it yourself, if the sketch is not behaving as you would expect it to, again, it becomes very difficult indeed. Okay, so one way to actually fix that is to break that down into a number of items. So there's an original DXF. So this model was built from importing a DXF. It's actually a plate from a Vortex drone. And the DXF has been imported into a sketch and then dimensions added onto that. Now you can see how much information is going on there. Now, if it's actually done correctly, okay, you can see it's actually reasonably well constrained this if I modify some of these. But even now, just modifying one of these dimensions, it's taking, I don't know, maybe a second, well, maybe a little bit less to actually just change that dimension value. And this is all based on having to solve all those equations to actually get the sketch to update correctly. Okay, so you can see that. So it just makes it a little bit more difficult if there's too much going on. So what I would suggest for something like this is to break it down into more manageable pieces. Now, again, with something like this, it might be easier to first of all look at the elements that make up the sketch. So from a first sketch, again, this is from importing from the DXF. But from the first sketch, you might want to consider, first of all, what is the most important part of the design. In this case, it's the holes and the slots because they are fastening the arms that the drone holds on. And this area at the front, I'm not sure what that's for. But from regards to the actual function of this particular component, it's the holes that are important. So reducing the amount of information in there makes it an easier sketch to manage. What you can do then is introduce a second sketch, which would be the external profile. Now, again, something as complicated as this, first of all, you might want to just model half of it and mirror it because there's a lot less detail to do. But you also might want to just work on, say, the front half, the back half, and then join the bit in the middle as well, simply because even now, there's still too much information in these sketches for my liking. And then finally, the third sketch is adding the vent detail or whatever that is. And again, from a practical standpoint, you should really be just creating one of these elements here and then using pattern and mirror capabilities either in the sketch or more preferably as a feature, again, which we'll take a look at later. So in essence, keep it simple. What you do have to realize, of course, is that although we have these sketches here, the first sketch is the holes, the second sketch is the external profile, which may be dimensioned from the holes, and then the third is the extra detail, which is of not much consequence. It doesn't matter which sketch orders these are in. You can go ahead and choose whichever sketch to create the first profile, and then you can just then cut out the profiles like so. So rather than trying to cram everything into one sketch to get this profile, break it down into smaller ones. And really, if you were designing this from scratch anyway, it would make more sense that you would do individual sketches for a lot of these features as you build it up. Just keep those sketches simple and you'll find the whole process of creating the sketches in the first place and getting them to update predictably a lot easier for you. All right. Okay, so let's talk about, we've had a look at sketching, keeping things simple, about sketch fillets, and about using constraints over dimensions. But what we'll take a look at now is really how we build a robust 3D model. If anyone's done any serious 3D modeling in the past, you will know that if you do make some design changes, and let's face it, apart from death and taxes, design changes are inevitable. So they're always going to happen. And suddenly you get this situation here where things light up like a Christmas tree, is what we say. Everything goes red. You've then got to go and systematically make changes. And then it just makes it a little bit more difficult if you've been a little bit blasé about how you add references. So we will look at different ways to think about different ways about adding references. And then we'll also do things like add fillets and shell features, mirror features right at the end as well. Okay, but before we take a look at building a simple, robust 3D model, I want to just talk briefly about how a parametric modeler works and what the implications are. Okay, from this simple diagram, hopefully I'll be able to explain how a parametric modeler works. Now, whenever there's a piece of geometry that is created in a model, whether it's the origin or the planes, or in this case there's a sketch with sketch edges and the sketch face, then there's a solid, there's edges, there's vertices, there's faces. Everything in the parametric modeler has a unique ID number. So you'll find that they might not be sequential like this 0, 1, 2, 3, 4. They might be a longer number, but the whole point is that they are unique. So when you create a new sketch and select the front plane, that sketch knows that it must go on the plane with ID number 2. It doesn't matter whether it's called front, top, or right. It's ID number 2. You create your sketch, and then when you extrude, the extrude feature knows that it should be using the face from sketch ID whatever. And then if you want to add some fillets, the fillets know they go on ID whatever edge. Now, these ID numbers are generated when the feature is first created, and they stay with that feature until that feature is until that feature is deleted, or there's an element within that feature which is removed. If those ID numbers are never recycled, so there's no way that you could modify a model and then suddenly a fillet will jump to another edge. But the thing you need to bear in mind is that if you add a fillet to the block, for example, and it's looking for edge with an ID of 15, and that edge no longer exists, then it shouldn't really become a surprise when the fillet fails, because it's looking for that edge and that edge doesn't exist. Okay, so with that in mind, there are certain things we can do to avoid this type of situation where IDs will disappear and therefore your model becomes fragile. So in essence, to create a robust 3D model, it's keeping sketches simple and also be wary of the references that you make between features. It's never really the feature's fault, it's the references that you selected when you designed it, which is why we have this graphic here saying, we can't agree who's doing it wrong and who's doing it right. Okay, so let's build a real simple model, and we'll call it block with hole because that's exactly what it's going to be. Okay, so with that in mind, so I have these planes and this origin. They have their internal ID. I don't need to know what that is. All I need to just be wary in the back of my mind that that's how the parametric modeler determines what is what within your model. So let's go ahead and create a sketch. Select the sketch plane, so there's one reference added. Okay, we'll go ahead and add a center point rectangle using the origin. That's another reference added. We'll put in, actually it doesn't matter about the size. Okay, so in that sketch there was only actually one reference added, which was to the origin. and both the edges and the face, which is used for extrude, have their own individual face for extrude or original ID. Okay, let's go ahead and extrude that, selecting the face. There's another reference we've taken. In this case, these types of references, there's no avoiding them because you need to select that face to actually extrude it. Let's go ahead and drag that out. Okay, and I'll hide the planes just for now, just to make it easier. But let's just change that color to make it a little bit easier to see. Okay, next thing we'll do is we'll create a new sketch on this front face. Okay, so there's another selection. One way to avoid that might have been to create a plane, but there is different ways. But that's also perhaps a little bit of a problem because of the reference that you select. Okay. So somebody's asking, is variables not a robust 3D modeling workflow? Yes and no. Really, unless you're creating something which is going to be almost like configurable, so you need a certain number of inputs to generate the model, then I would use variables. In a normal design, variables are not used so often. Okay, let's just go ahead and sketch a circle in here. We'll give it a dimension. And we'll also dimension it from this edge. Okay, and hopefully the experienced among you will know the pitfall that I'm getting into here. Now that's the reason that's gone grey is because that's picked up a horizontal constraint to the origin. So let me just delete that and change that back to a driving dimension. Okay, let's just place that down there somewhere. Okay, and go ahead and remove that guy. And just make it through all, just for the sake of it. Now the next thing we'll do is add some fillets to these outside edges. So we'll take these edges, and the reason I'm selecting it like this will become clear in a moment. But basically, selected all the external edges of the model. Let's make those maybe not so big, 10. Make those that size. Lastly, we'll just create one more sketch on the top, which again is going to be another hole. And when you look at a sketch, it's quite often that you might be looking perpendicular to the sketch plane, which is perfectly reasonable. When you do this, however, there is always the danger of picking references which are not good for a robust model. For example, I would say, okay, we're going to give that a diameter, and we'll pick that from this edge here and this edge here. Okay, so far perfectly okay. We'll go ahead and extrude that, remove through all. Okay, and there's my finished model. Now there's a number of references of here which are not ideal for creating a robust 3D model, and the main culprit here is the fillet. You might have noticed as I built the model, I added a few dimensions to the fillet edges. Now I might not have had a choice in this case because the fillet edges, that was all that was there for me to select, particularly in this dimension here, sketch here. The only edges available were the fillet. So first of all, from a good modeling perspective, is try and keep the fillets towards the end of the model, because if the fillets didn't exist at this point, I would never have made those bad references in the first place. But not to worry, we can fix all that. Now see what happens now is if I pick this fillet up and I move it before this sketch, drop it in there, you'll see this sketch has failed. Okay, why has that failed? Let's go and take a look. So it says some external references are missing. Let's double click on that, and you can see the dimensions are just hanging in space. The ID numbers, because I removed that fillet before the sketch, it effectively removed the edges that we were referencing. So those edge IDs no longer exist. What's nice is that those ID numbers are not lost forever because the geometry entities always remember what they are. So if I was to put that fillet back where it was, you'll see that the sketch will magically fix itself because those ID numbers reappear, and the sketch knows then what to do. Okay, so let's go ahead and make some changes to this, and we'll start first of all by deleting these two dimensions. Now, what I would recommend is, obviously it depends on how the model was built, but always try to reference the original sketch, or at least a sketch, when you're adding dimensions. So you'll see this very first sketch here. If we turn this on, okay, and sometimes what I might do as well is actually hide the part to make it easier to see what you're doing. But what you should really be doing is saying, okay, well, that we're going to dimension from this edge here and from this edge here. Now, the benefit of that is that this sketch is very unlikely to change. You know, it might change size, but the actual entities that make up the sketch are unlikely to change. So that means now, let me just turn the part back on. That means now I can do whatever I want with this fillet, whether I put it before or after, and the sketch remains intact because we dimensioned directly to that sketch. So we're not making any reference to the part apart from the face that we sketched on. We're referencing the sketch. So whenever possible, just go to that little extra effort to find the original sketch, or it can be any sketch really, but if it's from the original, the sketch which drives the parent of the feature you're creating, then that makes it a lot more robust. Okay, let's carry on. Let's move this fillet down to the end, and we're going to see that sketch 3 fails. And of course, because when we created sketch 3, we dimensioned to the fillet edges. So it's the same story, just back to front. The fillet edges don't exist at the time when this sketch is evaluated. So again, this sketch doesn't know what to do. You know, if you press final, they are actually there, but when they were actually generated, the sketch was regenerated, those fillet edges didn't appear. Okay, so there's a number of things we can do here. Again, let's just delete these two dimensions. Let's look in the top bit. Now, I want to try and avoid using model edges wherever I can, simply because of this fillet issue can be a big one. So there's a couple of things you can do. Again, let's just hide the part for make sense. Now, even though that sketch is perpendicular to this sketch, so the sketch we're working in, you can still pick that entity there. So you could dimension from there, and there's a vertex that you could use there. Okay, so we're still, even though we're not in the same plane, we're still referencing a sketch rather than a model face, again, which make it a lot more robust. If there is no vertex, you know, perhaps this is a circular profile, so there's no vertex there. Well, probably circular profile is a bad example, but what you can also do is when you dimension, if you rotate your models out of the sketch plane, you can actually pick a face which is perpendicular to the screen. So if you choose a face which is perpendicular to the screen, it doesn't matter where that fillet is, because this face remains. Okay, so again, we're not relying on model edges. Wherever I put this fillet, you can see that everything updates as you would expect. And I would recommend always put your fillets at the end, and then you'll never actually come into this. But remember, just stop for a moment and think about the references that you're creating. Try to reference datum planes, try to reference the origin, try to reference sketches rather than model geometry, and you'll be a lot more robust models, and things will update more predictably. Okay. What you'll see in the ebook is a list of do's and don'ts. I'm not going to go through all these, but this is just a screen grab from out of the ebook. So this gives you a number of do's and don'ts which you can use as a checklist for when you're actually modeling. So it's things like use layout sketches, use constraints, keep sketches simple, and just things like name sketches and features to make them easier to find. And then from the don'ts, things like don't dimension to edges, don't overcomplicate, don't use direct editing features. When an edit to an earlier feature will fix the problem. That's quite an important one, because sometimes you see users will, rather than go to edit original sketch to move something, they will just use a move face feature to do it. There's not really anything wrong with that. It just makes your feature tree longer. It needs more rebuild time. So it's better to go back and modify your original sketch or original feature definition to get the result you're looking for. The last don't on that list is about modeling unnecessary features like threads, which you shouldn't do unless you're 3D printing. And we'll take a look why. So in this section, we're going to look at what you can consider planning ahead with your design. Now, it's not always possible if you are working on a concept design to think ahead what you're going to do. Now, something like detail, when you are designing your own parts, they should have 100% detail on them, because you need to make sure they are manufacturable. You need to convey all the information to whoever's making it, so they can actually make it accurately, either from the model or from a drawing. However, there are certain items like bolts, nuts, bought-in items like motors, solenoids, and all this kind of stuff which is useful in your design, but it doesn't really add any additional benefit to you. So, for example, these two bolts here, the bolts on the left is over 50 times bigger with regards to the amount of work your graphics card needs to do. Every time the graphics card basically breaks down every single surface into a number of triangles, a bit like an STL file, and then renders those triangles on screen. The more small detail you have on there, the more triangles you need, and therefore the more your graphics card needs to do. So, do you really need the threads? Do you really need the bolt specification on the head? Of course you don't. The simple representation will be more than enough. Let me just take a look at this particular file in Onshape, which is that one. Okay, now you can build pretty much any geometry in Onshape, and there's also a number of custom features used here to do some angled text, and an M10 thread on there, which includes the runout as well as the exact thread profile. So it all looks very pretty, and you really only need to do this if you are 3D printing. If you're 3D printing and you need to have a thread on there, usually to screw into, then by all means create the thread. But if you're just doing a regular design, keep it simple. So that exact same bolt there has basically been simplified to this. Okay, and that's all you need. Now the difference being is that this assembly here, which is it's just 100 bolts. It's nothing more. It's not a lot if you're talking about a big machine design. And you see, it rotates, perfectly smoothly, or it might not over GoToMeeting, but it rotates perfectly smoothly. Now, if you export an STL of this file, it's around about about 5 megabytes. Okay, so even now, it's still a fair amount of triangles required to render those. Oh no, it's near 10 megabytes. So and this one, okay, it's the same 100 by 100 assembly using the threaded bolts. Actually, the graphics is okay. It's slightly slower than the simplified version. But the STL output on this is 540 megabytes and takes about 10 times longer to generate as well, because again, it's got to generate triangles for every single helical thread and run out on all these designs here. So just bear in mind, if it's not adding any value to your design, don't do it. Keep it simple. And if you import a supplier's model and it has too much detail, either consider asking them for a simplified model or simplify it yourself. You can do that using, if it's an imported model, it would just be a single import feature, but you can use all the all Onshape's direct editing tools. So you can use things like delete face. You could delete a lot of these thread faces and all the threads and all those, and move face and replace face, and all these options here you could use to simplify something like a motor model if you've downloaded that from a supplier website and it's just got a ridiculous amount of detail in there. Okay, next thing I'd like to talk about is Symmetry. We've already mentioned Symmetry once already with regards to creating sketches. So we had in the drone example, there was a lot of detail in there which could have been simplified by using Symmetry. But also when you're actually creating sketches as well, use those planes because that's what they're there for Symmetry, and also use the origin as the default for your particular design. Okay, in this example here, we're using it's a milk crate which might have a number of planes of symmetry, so you could break it down into one single quadrant. In fact, 1/8 of the actual design itself. And again, if we take a look, excuse me, if we take a look at that particular design, we can see that even now it is 71 features to build that, which isn't a massive amount. But if you were to do that all in one go, you can imagine where we'd be up to. So, for example, if I roll this back, you'll see that there's a lot of the detail has been created on this 1/8 of the model, and then at some point you will find a mirror feature. In fact, there it is. Okay, and then that's mirrored around the center, mirrored around a 45-degree angle. Okay, and in fact, let me just search for mirror here, would be easier. Okay. And then finally, it'll mirror all the edges, and then you can build the base in there. So it might not always be possible, certainly in your mind's eye, to plan ahead with Symmetry, but you could still create sketches that are complete, like we see here. So the sketch has been created for the entire side of the milk crate, but then only half of it's been used to create it. So you can still add your dimensions in for the entire part, but then just break it down into smaller, manageable pieces. It just makes your life easier. It makes the burden on the modeler easier, so you'll find things work much faster. Plus, then if you need to make some changes, they're a lot easier to do as well. Finally, we'll take a look at patterns. Patterns can be used to reduce repetition. What's unique about Onshape as well is being able to put patterns across multiple parts because we have the part studios. I would suggest avoiding sketch patterns where possible, simply because they're a lot more difficult to make changes to. Let's take a look at a quick example of where we can use patterns. Okay, so this is perhaps a simple example of a gear. We've got the basic gear shape, and we're just going to create a cutout. Now, it's not an involute or anything; it's just 3 straight lines, so it's nothing very technical here. But just to illustrate a point. Now we can use sketch patterns to populate this geometry. So select all those items, use a circular pattern, and then put in however many teeth we want. So let's put 30. Okay, there's nothing wrong with that, but what you'll see is that whenever you create a sketch pattern, the origins are never centered. So you'll see I can move this thing off. It looks quite funky, but and then if I snap it back to the origin, you'll see everything turns black, and that sketch pattern is fine now. Again, personally, I would avoid sketch patterns as much as possible and do it all in a feature. Okay, of course, you now can go ahead and remove that, like so, and that's absolutely fine. It's easy enough to edit. You can go in there and just change this, and if you want to make it, I don't know, 12, you can go ahead and do that. That's not a problem. But the issue comes when you want to make changes to it. If you wanted to change this profile from a straight line to an involute or just an arc even, then you basically destroyed your entire sketch pattern. Okay. Also, if you wanted to, let's say add fillets, some root fillets at the bottom here. Okay, just add those in there. Perfectly fine. But you'll see that doesn't propagate to the rest of my sketch. So I then have to go ahead and delete all these. Which, if you've made any references or any of your downstream features have made any reference to any of these, of course, then you're going to get yourself into trouble as well. So it's a good idea to leave those as is and use the and use a feature pattern. Sorry, rather than using a sketch pattern. Okay, I'm just going to jump back a little bit to back to where we started, which was, let's go to there. Okay, so there's my first sketch. Now, if I use a different type of pattern, this time I'm going to use the feature pattern. There's a couple of patterns types that we can use. We can use there's part pattern, there's feature pattern, and there's face pattern. Now, a part pattern would not work in this case because we've got a cutout. So if we rotated this around, the cutouts would consume each other. So you would suddenly get a blank disk with no teeth in. We could use a feature pattern. A feature pattern is very expensive with regards to performance, though. So a feature pattern will generate every feature as it's created. So if it's a complex pattern, it will take more time. The fastest by far is the face pattern. In this case, all we need to do is just select the faces you want to pattern, select an axis, which can be a face or an edge. Again, select faces rather than edges for references because they're a lot more robust, and then add those in. You see the speed of that was very fast. Now, what happens if you want to do the same design change? If you want to put those fillets in, okay, let's just go ahead and fillet these edges. Let's put something like that in. Now, if we were to do that, you'll see this pattern will fail, and the reason it's failed is because the number of faces has changed, but it's very easy to fix. So all you need to do then is just add in those new fillet faces, and the pattern will update for you automatically. So it just, not only is it faster, but it's also more robust and it's easier to edit if you keep your patterns in features rather than sketch. Use sketch patterns if you must, but please try to avoid them to make your models more robust. Okay, after you've finished a design, so we've looked at planning ahead with regards to creating symmetry and patterns and mirroring. It makes you can start to do other things with Onshape which you cannot with a traditional file-based CAD system, and those are versioning, branching, and sharing. Now, make a version whenever you get to a milestone in your design. It doesn't cost anything to make a version. You can make as many as you want. Perhaps it might make the version tree look a bit long, but it's not absolutely doing any harm. So once you get to a point within your design, create your version. Okay. Does mean then if you do make a mistake, you can go back at any point and fix it like you just saw me do a moment ago. Plus, it puts a stake in the ground so people understand that version is perhaps the version you're going to manufacture from, which then leads you to branching as well. Once you have a version, you can create a branch. Now, what is a branch? A branch is a sandbox, if you like, within the document you're working on. So it allows you to do what-if design scenarios, perhaps design parts which are not related to the main design, and it allows you to do these changes without changing the main design. So it's completely separate Multiple people can work in the same document in different branches or the same branch, and it just means it's an easier way to manage your data and manage your projects if you use versions and branching. And the final thing here is to share. Now, I know everyone here makes perfect designs first time, but it always helps to have another set of eyes look at your design. So use sharing. Share it with your colleagues. Share it with your customers. If you're a student, share it with your lecturer. All these just makes it very easy to give your design to somebody else, let them take a look at it, give your input, and if you give them edit permissions as well, they can also make those changes for you. So there's a lot of flexibility there within Onshape for version, branching, and sharing. And I always recommend to do those three things when you're finishing design, or branching if you're doing some multiple design scenarios. But certainly share your design with others and get input from them as well. Okay, that's about it. We'll wrap up now. We've covered quite a lot at a fairly brisk pace. All this information is in this ebook. You can download it from this URL. So onshape.com mastering-3D-modeling, and I will stay around for a few minutes to answer Q&A. If you've got any questions, please put them into the question dialogue. But again, thank you for your time and have a nice day.